this video, we're going to get through the full unit on the coordinate geometry of the circle. What's important here is there's two equations of the circles that we're going to be dealing with, but it is important to note that you might need to use the formula from the line. So what we're talking about here is you might need to use the distance formula, the slope formula, equation of the line, and so on. So it's just important to note that you might be still using the other formula that you used for the coordinate geometry of the line. So what we're starting off with here is the equation of the circle with a center 0, 0. Now this equation of the circle is always going to look like x squared plus y squared equals r squared. And anytime you see that equation, you know they're talking about, okay, a circle with the center 0, 0. So for example, if we had x squared plus y squared equals 25, then we would know that, well, the r squared is the radius squared. So r squared is equal to 25, which means r is equal to 5. And if we were to quickly draw that, okay, what we would have is our x and y axis, okay. If the radius is 5, it means that it's going to hit each point at 5, 5, minus 5, minus 5. If you're to draw that, you're going to use your compass. The center, remember, for x squared plus y squared equals r squared is always 0, 0. So your compass is going to be at 0, 0. And we're just going to put the pencil at 5, 0. And we're going to draw our circle. And that's why I stopped labeling the points on the other axis, because I knew it wouldn't be accurate. So because that's our point, what we're looking at here is that this would be 5, this would also be 5, this here would be minus 5, and this here would be minus 5. Okay, so we're hitting the x and y axis. But remember, the origin, which is 0, 0, is always the center for this one. So find the equation of the circle with the center 0, 0 and the radius 3. So first thing I'm writing down is x squared plus y squared equals r squared, because I knew once it said the center was 0, 0, this was the equation of the circle. All we're doing here is subbing in. The radius is 3, so we've x squared plus y squared equals 3 squared. So my answer is simply x squared plus y squared equals 9. Okay, so obviously this is the more basic type of circle. Next question, it says find the equation of the circle with the center 0, 0, which contains the point 4 minus 3. It's 4 minus 1. So what you're looking at here is, again, when it says center is 0, 0, first thing we're going to write down is x squared plus y squared equals r squared. Okay, if it says it contains the point 4 minus 1, that means on this line, okay, 4 minus 1, so say this is 4 on the x-axis and say minus 1 is here. If the center is 0, 0 and this here contains the point, that means it's on the circle, okay? And if you think about that, that means that this line here, okay, from the center to the point 4 minus 1, that would make the radius. So what we're looking at here is finding the length of the radius. We don't have the radius. They haven't told us what the radius is. So we need to find the length of the radius, which is actually the distance or the length of these 2 points, which means we're using our distance formula, square root of x2 minus x1 to be squared plus y2 minus y1 to be squared, which is one of our line formulas. So remember, we used to sub in our 0, 0, our 4 minus 1. But before we do that, I would have always labelled x1, y1, x2, y2. So we're subbing in here. We have the square root of x2 is 4 minus 0 to be squared plus y2 is minus 1 minus 0 to be squared. So we end up with 4 minus 0 is 4 squared, plus minus 1 minus 0 is minus 1 squared. 4 squared is 16, minus 1 squared is 1, so 16 plus 1 is the square root of 17. So that's our OR. So I'm going to go back here and we're going to sub in x squared plus y squared equals the square root of 17 to be squared. We're subbing into the formula. This is the radius, but the formula has squared. So we've x squared plus y squared, the square root of 17 to be squared, okay? They're opposite operations to each other, so when you put that into the calculator, they cancel each other out and you end up with just 17. And that's the equation of the circle. So just keep in mind sometimes, because we're talking about a radius, which is a straight line, we might need to use some of the formulas we used in the line to solve certain parts of different questions here. So just always be mindful of that. So find the length of the radius of the circle. X squared plus y squared equals 8. So we know the equation here is x squared plus y squared equals r squared. If we're finding the radius, we're going to let r squared equal 8. So r is equal to the square root of 8, which is 2 root 2, but either answer will be fine there. Okay, so when you're given the equation of the circle and they ask you to find the radius, we let r square equal the radius, which is 8. Okay, so let's move on to the next part. There's 3 different things we're going to look at here. So points and circles. Now we would have seen this before, you know, when you're subbing in for the line. But what we're looking at here is the point P is inside the circle if the distance between the center and the point P is less than the radius. Okay, so keep in mind we're still looking here at x squared plus y squared equals r squared. So what they're saying is if the point P, okay, if we find the distance between the center and that point P, and if it ends up as less than the radius, so we'll be given the radius in the question, then it obviously is going to be inside the circle. If the point P, okay, it's going to be on the circle if the distance from the center to P is the same or equal to the radius, and that makes sense, okay? If the distance between the center and P is the same as the radius, then it is the radius, okay? And then lastly, the point P is outside the circle if the distance from the center to the point P is greater than the radius, which makes sense because it's bigger than the radius, okay? So it has to be outside if it's bigger than the radius. So let's look at how this would be asked in a question. So is the point 1 minus 3 inside, outside, or on the circle x squared plus y squared equals 13? Now, we know a coordinate is going to be x and y. So all we're going to do is sub in to the equation of the circle using 1 minus 3. So we've 1 squared plus minus 3 squared equals 13. 1 squared is 1 plus minus 3 squared, minus by minus is plus, so 3 by 3 is 9 equals 13. Obviously these are not equal. 1 plus 9 is 10 and 10 is less than 13. Okay, so if we look at that, we have 10 is less than 13. So if it's less than 13, that means it's smaller than the radius. Therefore, the point is inside the circle. Okay, because 10 is less than 13. Let's look at another example. We have, is the point 3 minus 2, so I'm going to label that x and y, inside, outside, or on the circle, x squared plus y squared equals 13. So we've x squared is 3 squared plus y squared is minus 2 squared equals 13. 3 3s are 9 plus minus 2 squared minus by minus is plus 2 by 2 is 4 equals 13. 13 equals 13. Therefore, the point is on the circle. Okay, so that does come up quite a bit in the exam papers, so just keep an eye for that. There's 3 different ways you can be asked that. Now, at the start of this video, I said there was 2 different equations of circles, 2 different types of circles, okay? So this one here, we have an equation of a circle with a center hk. So this could be any point. Hk is just the letters or variables they're using. So any point, and the radius is obviously still r. This equation is x minus h to be squared plus y minus k to be squared equals r squared. Okay, so this is the equation of the circle, okay, where the center is obviously not 0, 0. And that's really, really important, that as soon as you see this, you think, okay, it's not the x squared plus y squared equals r squared, so it's not where the center is 0, 0. So let's do an example. It says find the equation of the circle with the center 2 minus 3. Now, the center of these circles is hk, so I've labelled it hk, and the radius is 5. So what I'm actually going to do is I'm going to sub in all of that information to this circle. So we've x minus h, so x minus 2 to be squared, plus y minus k, so y minus 3. So we need to be careful here with our signs, to be squared. And the radius is 5, but it's radius squared, so 5 squared. So minus by a minus inside here is going to become a plus, and we're just going to tidy this up. So our answer is x minus 2 to be squared plus y plus 3 to be squared, and 5 squared is 5 times 5, which is 25. And this is your answer here. You leave it in the form that it was originally given in. You don't multiply out those brackets, okay? And just an observation here is that if you look at the center being 2 minus 3, okay, and then you look at the equation, you've x minus 2 to be squared plus y plus 3 to be squared equals 25. You just need to notice at this point that the signs are the opposite. So 2 becomes minus 2, and minus 3 becomes plus 3. So instead of actually subbing that in the way I did and make sure we check signs and all of that, you could literally just put it into the formula, but you must make sure the signs of the center become the opposite when they're in the equation. Okay, and that's really, really important. Let's look at a couple of other examples here. So find the center and the radius of the circle. X plus 3 squared plus y minus 4 squared equals 8. Now remember what I said here. The center is going to be the opposite signs. So minus 3 and minus 4 is going to become plus 4. Okay? Because the h and k becomes minus h and minus k. So we always have to use the opposite signs. The radius, okay, so this is r squared. Remember the formula. So it's x minus h to be squared plus y minus k to be squared equals r squared. So r squared is equal to 8. Be very careful. It's not r equals 8. It's r squared equals 8. So if r squared is equal to 8, then r is equal to, remember the opposite to squared is square root. So square root of 8, and you can just leave it like that. Okay, so center is minus 3, 4, and radius is the square root of 8. And then lastly, we have the circle with a center 1, 3. passes through the point 3, 5, find the equation. Now, if we think of this on our diagram again, okay, we've our x and y axis, 1 on the x-axis and 3 on the y-axis. That's our center. Okay. 3, 5, so 3 is here. Again, obviously this is not accurate. 3, 5 passes through the point. So the circle passes through that point. Okay. Terrible drawing, but you get the idea. That means from the center to that point would be the radius. Okay. So we're looking for the length of the radius. And if we're looking for the length of the radius is a straight line. So we're using our length or distance formula, x2 minus x1 to be squared plus y2 minus y1 to be squared. So we're using our points 1, 3 and 3, 5. So I'm going to label x1, y1, x2, y2. So we've the square root of x2, so it's 3 minus x1 is 1 to be squared, plus y2 is 5 minus y1 is 3 to be squared. 3 minus 1 is 2 squared. 5 minus 3 is 2 squared. 2 squared is 4. 2 squared is 4. So we've the square root of 8 is the radius. Okay, so let's just keep this in mind what we're doing here. Now, remember you're not using the formula x squared plus y squared equals r squared because the center is not 0, 0. So our center is 1, 3, which is hk, and our radius is the square root of 8. And we need to sub in to the formula x minus h to be squared plus y minus k to be squared equals r squared. Now remember, when we've the center, the signs become the opposite. So the positive 1 becomes a negative 1, and the positive 3 becomes negative 3. And we've the radius squared is the square root of 8 to be squared. And remember, when we've the two operations, the opposite operations to each other, they're going to cancel each other out. So we end up with the square root of 8 to be squared is just 8. And that's the equation of our circle. So keep in mind, we seem to be using this distance or length formula because we're often looking for the length of the radius to sub into the formula for the equation of the circle. So that's really, really important. Now, intersecting lines and circles. This is where algebra very much comes back into play here. You have an x and a y axis. You have some form of a circle and you have a line. Now, if we're looking for intersection, what we're looking for is where does the line and the circle intersect? And if you think about it, what that means is we're looking for 2 points, okay? And each point has an x and a y. So we're going to do this by looking at an example. Find the points of intersection of the line x plus 3y minus 5 equals 0 and the circle x squared plus y squared equals 5. Now we are going to solve this by using simultaneous equations, but this time, okay, we don't have two lines. We have a line and a circle, so it works a little bit different to the more basic simultaneous equations. So step 1, okay, we have our line and we're going to let either x equals everything or y equals everything. Now in this case, it's easier to leave the x on its own on the left and move everything over to the right. So we end up with x equals minus 3y plus 5. So we haven't changed anything here. We've just rewritten the line, okay, so that it has either x or y on its own on the left. So from here, step 2, we sub in the x value into the circle. Into circle equation. So circle equation is x squared plus y squared equals 5. But instead of x now, we're going to replace it with minus 3y plus 5 to be squared plus y squared equals 5. Now what this allows for is instead of having two different variables, x and y, in the equation, we now have all of the same variable. We only have y's now in the equation. And if we've all the same variable, it means we should be able to solve it. So let's multiply out. So squared means minus 3y plus 5 times minus 3y plus 5 plus y squared. I'm actually going to bring that plus 5 over and leave everything on the left and let it equal to 0. Multiplying out back-to-back brackets, again, this is all algebra. Minus 3y times minus 3y, minus by minus is plus. 3 times 3 is 9, and y times y is y squared. Minus 3y times 5 is minus 15y. 5 times minus 3y is minus 15y. 5 times 5 is plus 25, and don't forget to carry along the plus y squared minus 5 equals 0. Now we need to tidy this up. We've 9y squared plus y squared minus 15y minus 15y and plus 25 minus 5. So we end up with 10y squared minus 30y, 25 minus 5 plus 20 equals 0. So we end up with a quadratic that we need to solve. But the first thing I'm going to do here to simplify and make my life easier is divide all the way across by 10. So we end up with y squared minus 3y plus 2 equals 0. And we're going to solve this using our back-to-back brackets. So back-to-back brackets, we have y times y gives y squared. 2 times 1 is 2. Positive constant means the signs inside the brackets need to be the same. Because we have a minus 3, we're going to have a minus 2. Minus 1 is minus 3. We let each bracket equal to 0. So y minus 2 equals 0. Y minus 1 equals 0. So y is equal to plus 2. And y is equal to plus 1. Now remember what I said, going back to the picture up here. We're looking for 2 points. So an x and a y and an x and a y. At this stage, we only have 2 y values. So step 3 is sub in your 2 y values to the line to find the 2 x values. And the line was rewritten as x equals minus 3y plus 5, x equals minus 3y plus 5, y is equal to 2, and y is equal to 1. So we've x equals minus 3 times 2 plus 5. So x is equal to minus 3 times 2 is minus 6 plus 5. So x is equal to minus 6 plus 5 is minus 1. So this point of intersection is minus 1. And we use the value that we subbed in to get that, which is 2. And here we have x equals minus 3 times 1 plus 5. So x is equal to minus 3 plus 5. X is equal to minus 3 plus 5 is 2. So we've 2 and 1. Okay, so your 2 points of intersection. And remember, you're always looking for an x and a y and an x and a y. So that's really important and comes up quite a lot. So remember, you're always going to end up with a quadratic equation that you need to solve. That's going to give you either your 2 x values or your 2 y values. And then step 3 is subbing those 2 values into the line to find the other 2 values. Okay, nice question because it's quite algebraic. Let's look at another one. We have shown that the line 3x plus y plus 10 equals 0 is a tangent. Okay, that word we've seen before. to the circle x squared plus y squared equals 10 and find the point. Now what that means is we have a circle. A tangent is a line that hits off or goes through at one point only. Okay, which means there is only one point of intersection in this question. So like when you're reading that question, that's what you should be thinking of straight away. Okay, there's only one point. So let's look at our information. We've 3x plus y plus 10 equals 0. And the circle is x squared plus y squared equals 10. Step 1 is rewriting this. Now I'm going to leave y on its own this time because the y is already on its own. There's no coefficient in front of it. So we're going to bring over the others. We've minus 3x minus 10. And this is our value that we're going to sub in to x squared plus y squared equals 10. So we're going to write down x squared plus y squared is minus 3x minus 10 to be squared. And I'm going to bring that 10 over, so it's minus 10 equals 0. Multiplying out that bracket, we've x squared plus, we've minus 3x minus 10 times minus 3x minus 10 minus 10 equals 0. So we've x squared minus 3x. So I'm just going to leave that there just in case our signs are different. So minus 3x times minus 3x, minus by minus is plus. 3 by 3 is 9x squared. Minus 3x times minus 10 minus by minus is plus. 3 by 10 is 30x. Minus 10 by minus 3x minus by minus is plus. 3 by 10 is 30x. And then minus 10 by minus 10 minus by minus is plus. And we have 100 there. Now the brackets are actually not necessary because they all ended up to be positive. Now we've plus 100, but we've minus 10 at the end equals 0 there, which is important. So we've x squared plus 9 squared is 10 squared. Sorry, 10x squared. So x squared plus 9x squared is 10x squared. 30x plus 30x is plus 60x. And 100 minus 10 is plus 90 equals 0. And what you can see here again, I'm able to divide all the way across by 10. Now that's important. You should always look for some sort of common denominator here that we can make the quadratic easier. So 10 divided by 10 is 1. So we've 1x squared. 60 divided by 10 is 6x. 90 divided by 10 is 9 equals 0. Back to back brackets, x by x is x squared. Factors of 9 is either 1 by 9 or 3 by 3, and we're going to use 3 by 3 because the 3 and the 3 will give us a 6. So we're looking for the same signs because the constant is positive, and because we're looking for a plus 6, they're both going to be plus. Now what you should notice here, we have the same bracket. And this is because there's only one point of intersection. So we don't need to use both brackets because it's going to give us the same answer. So the point of intersection is at x equals minus 3. But remember, we need to also find the y value by subbing the x value into the line. So y is equal to minus 3 times minus 3. Remember, x is equal to minus 3. Minus 10. Minus by minus is plus. 9 minus 10, so y is equal to minus 1, so the point of intersection is minus 3 minus 1, and that's one point only. Okay, and the last small thing we need to look at, and we've seen this before, when a circle is intersecting the axes. So we could have a line intersecting an x or y axis, or we could have a circle intersecting an x or y axis, or we could have a curve like a U-shape or N-shaped intersecting an X and Y axis. So what that means is anytime it says intersecting the X axis, we let Y equal to 0. Okay, so keep in mind what's happening. Where this circle intersects the X axis, the Y value is actually 0. So that's why we're letting Y equal 0. And where the circle intersects the y-axis, which is here and here, the x value here is equal 0. Now this is the same for a line intersecting, a circle intersecting, any other function intersecting an x or y axis, you let the opposite equal 0. So for example, find the coordinates of the points where x squared plus y squared equals 16 intersects the x-axis, we let y equal 0. So we've x squared plus 0 squared equals 16, x squared equals 16, x is equal to, the opposite of squared is the square root of 16, so x is equal to 4. Now when it's the square root, it can be plus or minus 4. So what we have is minus 4 by minus 4 gives us plus 16, and plus 4 times plus 4 gives us plus 16. So if x is either positive or negative 4, it means there are 2 points. Remember, it's intersecting the x-axis at 2 different points. Okay, so the 2 points are plus 4 and 0. Remember, we let y equal 0. And minus 4, 0. And the next example, find the coordinates of which x plus 3 to be squared plus y minus 2 to be squared equals 10 intersects the y-axis. We let x equal 0. So here we have 0 plus 3 to be squared plus y minus 2 to be squared equals 10. Now there's a little bit more work in this question because it is the circle where the centre is not 0, 0. So there's going to be a little bit more work involved. So let's tidy it up first of all. 0 plus 3 is 3, and 3 squared is 3 by 3, which is 9. We have plus y minus 2 to be squared is y minus 2 times y minus 2. I'm just going to bring the minus 10 over and let it equal to 0. Sorry, the 10 moves over and becomes minus 10. So multiplying out that bracket, we've 9 plus y times y is y squared. We have y times minus 2 is minus 2y. Minus 2 times y is minus 2y. Minus 2 by minus 2, minus by minus is plus, and 2 by 2 is 4. Minus 10 equals 0. Tidying all of that up, we end up with y squared. Minus 2y is minus 4y. And we have 9 plus 4 is 13. And 13 minus 10 is 3 equals 0. So what we end up with here is a quadratic. And in that quadratic, okay, we're using our back-to-back brackets to solve it. Y times y is y squared. Factors of 3 is 3 by 1 is 3. Signs have to be the same, but we're looking for a minus 4, so it's going to be minus 3 minus 1. So we're going to let each bracket equal to 0. Y minus 3 equals 0. So y is equal to 3. And y minus 1 equals 0. So y is equal to 1. So the 2 points, remember we let x equal 0. So it's 0, 3 and 0, 1. And they're your 2 points of intersection. And that's the full chapter, the full unit on coordinate geometry of the circle. It's a little bit shorter than coordinate geometry of the line because you already have all of that information already from the line. So you kind of have a background already. So the best thing to do from there is to practice exam questions on coordinate geometry of the circle. And you should see all of the similarities of what we did in the video there.